written a script to calculate a temperature profile inside the rod. The x-axis here is r equals 0 to 1, and this y-axis is temperature. We had to guess the temperature at the middle at 350 degrees in order to calculate a temperature profile, but that temperature profile gives us a temperature at r equals 1 that is actually too high. We need to satisfy this boundary condition. We need that temperature at r equals 1 to be 300. So the problem asks us to use the false position method to accomplish that. So let's take a quick look at the false position method function. We need to give it a function that would be 0 if our input alpha is correct. So we're going to define this function as the difference between the calculated temperature at r equals 1 and 300 Kelvin. So in other words, this number minus 300 Kelvin. So right now, f of alpha would be about 47.5. And we need a low guess, we need a high guess, and we need some sort of error tolerance. And then it'll output the series of guesses and XR values. So let's start just by fiddling with the numbers. So we know that 350 is too high. The problem says to guess between 300 and 400, so 300 must be too low. So if we guess 300 for alpha, we get a temperature at r equals 1 as being less than 300. So it is definitely too low. In fact, we probably don't even need to go all the way to 400 as the problem requests, but I guess it doesn't hurt. If we guess 400, then we get something that is much higher than 300 at r equals 1. So what we're going to do is we're going to say our initial guesses are 300 and 400. We have to define f, and then the EA max can just be something reasonable. So let's make a function that I'm going to call it root finding rod temperature, and the input is going to be alpha, and then I'm going to call this T1 or TR1 error. Okay, so TR1 error, I like a capital E here, is going to be T series end minus 300. Okay, so we have to actually calculate the T series, and we can pretty much use the script that the code that we have from the script. Okay, since we know this code works, I'm just going to use an even smaller step size. Might as well. So let me just make sure. So this function inputs an alpha. That alpha goes into the initial guess, and then we solve the rod temperature profile using fourth order Runge-Kutta. We extract the T series, and the last number should be 300. Okay, so let's go ahead and try this out. Okay, so I'm going to comment this stuff out for the moment. And I'm going to run I'm just going to run the function. So we're going to start with 300. So we get a negative 2.5 if we input 200, or 300 as our guess. If we input 400 as our guess, then we get positive 97.5. So in fact, we now have a function that at least crosses 0 depending on the input that we give it between 300 and 400. So now let's run the false position method. Okay, we actually only really care about the XR series. Okay, we're going to guess 300, 400. The input is going to be at root finding rod temperature. And let's use a small error. And I'm going to say correct alpha is going to be let's see how that goes. Okay, so it's saying that the correct alpha is 302.5. Okay, so now let's actually let's not use this alpha, but rather the correct alpha. And if that's right, then we should be done. Okay, so now at r equals 1, we touch 300, just as we expected. It turns out the temperature at the middle is actually 302.5. So this is the final solution for the problem. You should probably label your axes. Make sure that's actually right. What did I do? Okay, so that is the right way to label an axis. So I'll go ahead and label all right, temperature versus R. That is the final answer to the problem.